We've got engine start.
So rises a new era of American spaceflight.
Welcome. I'm Deputy Administrator of NASA, Pam Melroy. Thank you for your interest in joining us today. Today, we're soliciting input from our workforce, our partners in industry, academia, and nonprofits, as well as the public, around our Moon to Mars objectives. We have set as a goal to create a blueprint for sustained human presence and exploration throughout the solar system. We will develop this blueprint and practice it on the Moon with the goal of demonstrating it on Mars. And to that end, we have developed a set of objectives that must be achieved, and we'd like your feedback on them. I'm proud to introduce our Associate Administrator for the Exploration Systems Development Mission Directorate, Jim Free, and our Director of Space Architecture, Spuds Vogel. They will share the foundations of our strategy, our methodology, and the work we've done, as well as our continuing work to provide context for these objectives. Over to you, Spuds.
Thank you very much, Pam, and hello, everyone. I'd like to give you insight on our methodology for the Moon to Mars strategy and its underlying principles. By way of preview, those underlying principles are to be goal-based, to have constancy and unity of purpose, and to have improved communication and engagement, both inside and outside the agency. We're also sharing the 50 top-level objectives to meet our goal and are seeking your comments. The space sector has grown since we first started down this path, and so we're soliciting input from a broader base of players to ensure that we are working to a common set of objectives that can cross timeframes and can prioritize investment dollars on an endeavor of this magnitude. NASA wants to be transparent, and we're soliciting inputs that we can go together on this journey of sustained exploration. But first, I'd like to quickly share some observations and things we need to consider as we strive to build advocacy for a unified approach. Before coming to NASA, I worked at DARPA, the Defense Advanced Research Projects Agency, where they utilize a systems engineering process called the Hellmire Catechism. The first question in the Hellmire Catechism is, what problem are you trying to solve? Or what are you trying to achieve? At NASA, we aren't trying to solve a problem per se, but we do need to begin our system engineering process by answering the question, why send humans into space? How does it benefit our citizens? And that question has many different answers. In fact, ask 100 people and you're likely to get 100 different combinations of these diverse interests based on what is important to them. But those diverse answers can generally be binned into three main categories that form foundational supports for this pedestal of value to the taxpayers. For some, this is a one-legged stool. For others, the weight shifts from one leg to another as geopolitical situations change. But in the end, the support for this wide platform is a weighted balance of all of these motivating purposes. That wide pedestal then forms the foundation for an optimal systems engineering process. Upon that foundation, leadership determines the what, which is to say the goal or the objective. And to court success, the what should have three key characteristics. It should be defined with enough detail such that we know how to truly judge success. It should have been developed with sufficient rigor such that we know it is reasonably achievable. And it needs to be consistent. Can't keep changing the goals. The leadership, having defined the what, now empowers the experts to go execute and flesh out the elements required to achieve the goal. This is typically done by something akin to a program office. For Moon to Mars here at NASA, that's Jim Free's organization. And they must be funded sufficiently to accomplish the objective. The elements themselves come from a balanced river of technology development that ranges from conceptual ideas that are the seed corn for future programs to mature technologies that started off as conceptual in a prior generation and have matured and are ready for transition to the current programs. There are multiple tech development paths here at NASA. One is an entire mission directorate dedicated to systems and tech development. Programs also do some of their own tech development. And then, of course, there's two other sources of tech development in this domain, and that's our industry and our international partners. They have their own. So most would agree that this is what optimal systems engineering looks like if done well. However, going forward, it's important to recognize many of the pitfalls that can challenge good systems engineering. Broad goals leave too much room for interpretation and will usually not end up satisfying the whys. Constantly changing goals means we're always spending money, but getting nowhere fast. Insufficient funding turns a program into level of effort, meaning they slowly fund portions of some elements to the limit of their budget without giving the program the full treatment it needs to accomplish the goal. Typically, level of effort is okay for technology development, but it generally makes programs inefficient and unsuccessful. External stakeholders can sometimes cause grief for a program by aborting the rigor that goes into defining technical solutions and injecting their own solutions that might be based on non-technical reasons. This starts to warp the wireframe of the technical solution, sometimes to the point that the wireframe no longer resembles a solution for the goal. Any combination of these external hindrances might then cause unhelpful cultural behaviors within an organization. People do not clearly understand a unified plan. They become fearful if their particular project will be cut. So they secure themselves in stovepipes, limit communication, and protect their projects while they envision how their project might fit into the next vaguely defined what that is sure to come down the road. External stakeholders seeing this and getting variable answers to questions become dissatisfied and become motivated to help more, which drives the internal cultural reaction even deeper down a path, which creates even more concern from stakeholders. So that cycle creates an unsatisfying result. So let's create a better cycle. The roller coaster ride that we've been on for the last 33 years from Moon to Mars started back formally with the announcement of the Space Exploration Initiative by President Bush 41. Well, it's been 33 years since then, and we're still on that roller coaster ride. And in the wake of multiple shifts in approach, there is widespread stress and anxiety, both inside and outside the agency. So for one of those large shifts in approach a decade or so ago, there was a necessary shift at the time to make the best with what they could, and that was to shift into a capability-based framework. And that's another way of saying level of effort, as I mentioned before. This is where we're saying, well, what can we do with the budget that we have? And that can be an okay approach, except for you're not going to be moving out with purpose, and it doesn't fully support a long-term strategy, at least if you're trying to accomplish something in the wake of, in the face of competitors. So what we want to do is have an objectives-based approach or a goal-based approach. So we have to think strategically, we want to be resilient and flexible at the same time, and we want to do this in a unified way. And so when we talk about those three principles now, first, architecting from the right. We want to be goal-based or an objective-based. You have to start with the thing on the goal on the right-hand side that you're trying to achieve, and from there figure out what elements are needed to flesh out that architecture. And then only from there do you then execute from the left. Granted, this is a clean sheet of paper approach to this, so we're not dealing with a clean sheet of paper here at NASA, and I'll talk about that in a moment. But that first principle is architect from the right, or be goal-based. So once we've established that rigor in architecting from the right, the next principle is we want to stick with the plan. We want the constancy of purpose. What do we mean by that? Well, if we have that wireframe that says, here's the plan, but then surely we're going to end up in a situation where we say, okay, we have limited funding. There are two schools of thought. One school of thought is to alter the plan, where you abandon the plan on the left and alter the plan to match so you can fully fund some other goal. And it's a totally different goal. It probably doesn't have the same rigor that went into the wireframe on the left. And you've got a new baseline from which future cuts will occur. But most importantly, you lose pace on the original goal that you had because you've abandoned it. Another way to deal with the limited funding is to stick with the plan and adjust to the funding that you'd received by prioritizing and preparing for more fruitful days. You've got constancy of purpose now. The progress is slow, but you maintain your technical credibility. That's important for technical resilience. I'd received feedback that this is very similar to the approach that we have been taking in the past, that we did architect from the right and we were sticking with the plan some 10, 15 years ago. But unfortunately, what happened is that was the initial attempt to prioritize and prepare for more fruitful days. But then over time, there was a perceived or real disincentive to communicate about the rest of the wireframe. So what happened over time is the communication or the engagement about that external wireframe started to fade, and we lost clarity on the overall plan, even though we were still doing these decentralized efforts. Now, if you were closer to those efforts, you could definitely see how it all connects together. But if you had some activity that was further away from that, and there was no unified architecture that we were all talking about, it was hard to see how you connected. So people had their own ideas of how they connected into this. So what we want to do is get back into a unified approach with a constancy of purpose where everybody is communicating from the same sheet of music and we all have the same plan. It not only helps NASA and our funding in trying to prepare for more fruitful days, but it also helps our industry and international partners to have a consistent visualization of what their opportunity paths are in this plan. And then over time, as we maintain this constant drumbeat, the external stakeholders hopefully start tapping their foot to the drumbeat. We, both inside and outside the agency, start tapping our foot to that same drumbeat. And then over time, those funding shortfalls hopefully start filling in. So we want to stick with the plan that we have architected from the right in a unified way. These principles help us maintain our technical credibility, as well as help us brave the storms of funding woes. And that technical resilience and financial resilience also feeds into political resilience with our external stakeholders, as well as administrations. And all of this resilience feeds back on our principles and galvanizes them, which in turn reinforces the resilience. And this is where the third principle of communication comes in. Communication is the lifeblood that drives this reinforcing cycle. Communication and engagement are the catalysts that ensures understanding, unity, constancy, technical credibility, and ultimately the best chance at a satisfying result. We have a federated board at NASA whose membership is made up of senior leaders from the mission directorates and charged with promoting consensus, resolving conflicts, and providing advice to leadership. Having the federated board helps not only with unity of purpose, but it is also a solid source of communication within the agency. So now let's talk about those 50 framework objectives that we want your feedback on. First, let's go back and look at the activities and the campaign segments that we've been advertising that we're going to do. And there's a lot of solid, good work going on in there. There's nothing wrong with them. Those campaign segments are valid. They show how we're going to be doing analog activity on the lunar surface and how that helps us with the Mars mission. But if we're not careful and staying too much on that capability-based framework, it could look as though we're just going to Mars to do some science for one mission and coming home, and that's it. That's the end of the story. When we all know that's not it. There's got to be an overarching goal. Remember, we had these underlying whys, the answer to the question of why, the motivating activities that we want to support for our citizens. And so if we aren't careful, we look and we don't have that wireframe of the ultimate goal and the architecture that goes around it. Again, it just looks like a cloud pattern of things that we're putting together. So we're trying to avoid that. So we want to define what that goal is, what the rightmost thing is in our architecture as we architect from the right. What is our ultimate objective? And Deputy Administrator Melroy, in cooperation with the rest of NASA leadership, defined that goal. It is to create a blueprint or framework for sustained human presence and exploration throughout the solar system. And so with that and asking the mission directors to challenge her on that, we arrived at that as the goal. And then she further challenged the mission directors to come up with that first top level layer of objectives as you come left off of that rightmost goal. What are those top level objectives as we build out the architecture? And she binned them into 4 different categories: transportation, habitation, infrastructure, operations, and science. And so that's what they did. The challenge was to derive those objectives and then reach consensus on them using federated board processes. But to reach consensus on those objectives, we first had to scope them properly, because that's a very broad goal that we're after, to do something throughout the solar system. So to bring it back in and look through the lens of, well, every time we go somewhere, there are multiple reasons that you could be going somewhere. Well, 2 main ones is what you'll hear about. Some people say that the whole reason to go somewhere is to have presence there. Other folks will say the only reason to go somewhere is to practice for the next step. I submit that every domain we enter, including a planetary body, we're doing both. If we want to have a blueprint for sustained human presence and exploration throughout the solar system, we have to do both to achieve that goal. We did it in Leo. We're going to do it here as we go on to the next domains. So to bound this scope, what we did to make it more digestible is we did both reasons for the moon, both presence as well as practice for the Mars demo, and then the Mars demo itself. Keeping in mind, we're doing a demo. We're not just doing a mission that is the end all. We're doing a demo for future activities in the rest of the solar system. We're going to leave the presence on Mars, the sustained presence on Mars, for the next generation. And by next generation, I mean the next 5 to 10 years. We'll take another look at this and increase the scope at that point. But for now, the scope was bounded by the 2 reasons for the moon and then the demo on Mars. So as I talked about before, the principles are architecting from the right, etc. So architecting from the right, we start with the blueprint. The mission directorates then brought to the table the top 50 objectives. We reached consensus in the federated board about those objectives. And again, if we were starting with a clean sheet of paper, Jim Free and his team would have to then architect this from that direction given all the way on the right and go all the way back as you come left with more qualifiers and requirements, ultimately working with the mission directorates and the centers to then create those elements that fill out the architecture. Obviously, we're not starting with a clean sheet of paper, and I'll talk about that in a moment. With this video, you're getting access to all 50 of the objectives. And so what we want to do is give you just a quick sampling of those objectives. We are very particular about the words we chose. In some cases, like this one from transportation habitation, we're talking about developing things. In this example from the lunar infrastructure, we talk about demonstrating things. Key difference in those, as an example that you'll see in our glossary, if we're demonstrating something, we're just doing the initial capability, hoping that our partners, industry, international, et cetera, will take the next steps in helping to build out a robust economy, for example. If it says develop, it means that we're doing the full capability to meet our objectives. Operations had a suite of 11 goals. This one is an example of how we're doing a build-up approach in other environments to prepare for the Mars missions. And then science had something along the lines of 17 goals, I believe. Some were spread throughout the disciplines, and some were basically looking at how we go about collecting the science, or the unknown unknowns. So you're going to see all 50 of those objectives. Now, the first step, as I mentioned, is to recognize, after we've developed these objectives and we reach consensus on them, including with your input, is we have to face the reality that we're not starting with a clean sheet of paper. We actually do have current efforts that are ongoing. Some have been going on for quite some time. Some are just getting started, and some have just started recently. So what we have to do is we have to build this bridge between the objectives and the current efforts. And as we build that bridge, it would be perfect if we could get perfect alignment on either side of this. But the reality is there's probably going to be disconnects. And some of those disconnects will fall in the category of an objective that is not being met by any current effort. In that case, we need to start something. Another kind of disconnect will be a current effort that is not tied to any objective. If that's the case, we have to ask ourselves, is that an effort we shouldn't be doing? Or is that effort really for something else that's beyond? We should be doing it, but it's not for this program. Or are we missing an objective? And that's part of this washing process that we're doing this summer, in part with help from you. There's another kind of disconnect that we could expect where you've got multiple current efforts that are attacking a single objective. And in that case, there could be manifold reasons for that disconnect. One, it could be that there are things that we're not supposed to be doing as it relates to the Moon to Mars, or it could be that we're missing objectives, one or more, or it could be that maybe a subset of that is maybe what the objective that we're missing is that we're purposefully taking redundant approaches for diversity of thought so that we'll have risk reduction on that particular objective because all of the technology is such low technology readiness level. But we're going to be conducting that gap analysis on the federated board to look at bridging that gap between the objectives and the current efforts. And I'll talk about that in a moment. But first, let me introduce Jim, who's going to talk about what the architecture looks like today as we advertise things today and the planning going forward.
Thanks, Spuds. Appreciate the introduction, Pam and Spuds. So let's first talk about how we architect today. And I'd like to share with you on this chart the process we use that starts with a strategic analysis cycle that you see on the left of the chart. That cycle has a number of inputs to it, one of which is first our overall strategy and budget that we align the architecture to. We look at the capabilities and technologies that are available both inside and outside the agency. We understand what our current programs can do, what their lift capacity is, what their total crew is, what their return capability is. And then we look at where we're going and what utilization we need to model our architecture after. And that cycle then, strategic analysis cycle, works along really 5 elements. First, it balances all that in the entire Moon to Mars campaign. It looks at specific parts of that campaign and how the architecture is developed around the concept of operations or mission objectives. We look at specific formulation of elements of all of the goals that are input. What do we need to do in the formation of an element such as the surface habitat or the transhab? We do a lot of modeling and simulation to play the objectives and requirements against the elements. And in some cases, we actually even do some prototyping or some human in the loop testing to validate the objectives or give further input for future strategic analysis cycles. When we complete that cycle, we have a number of outputs. We have inputs to our budget process, which help us lay out our plan in our 5-year budget horizon. We understand where we have gaps in capabilities so we can fill those gaps. We look at changes we need to make in existing programs that might limit what we want to do with our entire architecture. We also then look for new programs that we have to start to fulfill those objectives, or new partnerships with our international partners that we need to start to fulfill the objectives. And all of that then goes into our implementing organizations to go actually execute. So moving on from our strategic analysis cycle plan, we really have 4 areas of focus. The first for us is what our deputy administrator has asked us to really focus on as we look at our architecture development, and that's with an emphasis on science. Everything within all of our elements connects to the why we are going. Our architectures enable the science. For instance, in situ resource utilization. What do we need to take and where do we need to go to maximize, to get ISRU science back, and then also use ISRU as a tool on the surface to do further exploration and science gathering. Our next focus is the annual missions. We want to get to a cadence of doing our missions annually so we can maximize that science, maximize the utilization of our systems on the surface of the moon. And we start with the 2 crew, initially moving on to 4 crew, which is the ultimate test of our systems that we're trying to validate before we can go on to Mars, which is our next focus. So we're trying to use the moon and space station and future commercial LEO as analogs for our Mars missions, both of our systems and of the human system as well. We're also looking to do our robotic sample return to understand the volatile composition as well. And our 4th focus area is our partnerships. Our international partners are invaluable to us executing today on space station, and also what we've laid out in the current Artemis program and our future missions as well. And that is existing partners and new partners that we'll have moving forward. We also have our industry partnerships, which span many applications, from delivering direct hardware to us to sharing of data, and future ways that we'll partner with industry as the space industry expands. And as we move from our focus areas to our Mars missions, what I'd like to share with you is a conceptual Mars missions. So when we take a step back, Spud showed you the scope chart of what the objectives entail. We take a look at what we need to do a 30-day surface mission on Mars. What are the minimal capabilities we need? First, at the top, you see we need that transhab, and we need our propulsion to get us there. In this particular reference architecture, we use the hybrid propulsion stage to get us there, meaning chemical and electric. But before we take our crew, we know we need to get provisions there for them. And that's first doing a pre-deployed cargo lander with an analysis that shows we need the 25-ton class payload. We need some of the propellants sent ahead and surface power. We then would need to send ahead the crew ascent vehicle. We need to make sure we know we're going to get them off the surface. And then finally, the crew, which in this reference architecture, we've landed in a pressurized rover. Our assumption here is the crew will be deconditioned and will need as much time to adapt to the partial gravity. But we want to maximize the science, so we allow them to drive around before they become conditioned enough to get in the spacesuits and walk, and maximize that science in 30 days. When we take a step forward and move on to our trajectories, this is an example of an opposition class on the left, or a short stay mission, and a conjunction mission on the right, which is long stay. I'll draw your attention to the 2 boxes there. You can see the outbound durations are about the same. The surface stays are drastically different, and the return is about 50% less for the long stay mission. So our analysis says we have a significant logistics strain to support a 500-day surface mission. We've done that analysis. We've tried to do the cost associated with that. We also then look at what the logistics strain is for a 30-day mission with the longer returns. We're balancing trades. We determined that for our initial reference that you saw on the previous chart, that we felt like a 30-day was something that was more supportable than the 500 surface day stay. Now, it's up to us to show our work. Our deputy administrator has challenged us from the day she came on the job that we need to show our work so that people understand how we arrived at these conclusions. You'll see in the coming months some very short white papers to describe some of the parameters I just described to you here, to show our work for further understanding and feedback that others may have after you look at the objectives, after you take a look at some of the reference architectures that we've put together. So as we move forward from these reference architectures onto our next steps, we take a look at how the moon and Mars are connected. Spud showed you a version of this chart from before, but our connectivity in defining our architecture is making sure that we get the time on our systems on the lunar surface, understanding how they're connected to what we want to do on Mars. That also applies to what we're doing in lunar orbit on Gateway. So we need to understand that connectivity. We need to understand the total time we want on these systems before we say we're ready to go on to do those demonstration missions to Mars. And as we move on from the connection between the lunar surface and Mars, I'll show you an example of a graphical result of our strategic analysis cycle, a representative. As you saw in those cycles, we have a lot of assumptions, a lot of inputs. They drive a great deal of timing. They drive a great deal of content. So as you look at this chart from left to right, you can see our progression from low Earth orbit to the lunar return to potential Mars missions. Again, this is not our blueprint. This is one of the outputs. So we understand how the system fits together and how we can then plan our budget. Ultimately, we need to tie our budget to what our architecture is so that we can say to all of our stakeholders, this is when we want to go, and this is what we believe the cost to be. So you can see the progression of the rows with crew. First, where we're in LEO today, operating the incredible International Space Station, moving on to Gateway and lunar surface missions, and then the increase in crew number and also duration on the surface, and then the elements we need to make that happen. You can see the cislunar as we grow there with first starting with our comms, going on to our gateway elements, building up that capability, and then supporting it logistically with things such as the HTV. On the surface, you can see us growing from our initial Artemis 3 landing, growing with our LTV, moving on eventually to a pressurized lander, and then the cargo landers that support us for those longer stays on the lunar surface. We, of course, work closely with our other mission directorate partners in space technology and science. I said our support is to science, but we use the technology being developed in STMD to help enable our missions as well. And then on the Mars line, we are completely tied to understanding what's being done today on Mars with SMD. And then you can see as we start to build up for our Mars missions that even the logistics just for a 30-day mission start much earlier. So with that representative, and as we move on to where do we go from here, our architecture work goes into 7 different bins. First, we're working right now integrating the objectives that you will see and that Spud's talked about to perform a gap analysis. We have to understand that architect from the right and build from the left, where do we not intersect today, or where do we not have enough intersection with those objectives, and call that out. We then have to develop what is our architecture strategy to fill those gaps. We need to closely integrate with our other agency stakeholders. I talked about space technology, but as our forefront, the Science Mission Directorate. with all of that to be performed in an architecture, where do we reach out and find those international and industry partners through engagement to understand their goals, to understand how we can fit together to achieve our objectives? We then take and mature our options in the architecture, and you'll hear some more about that timing. We need to then begin to formulate what future architecture elements do we need. I talked about a surface hab, a transit hab. We need to formulate those, lay those into our budget, and begin that development when we can afford it, but when it meets the timing of the architecture that we've laid out. And then we need to make sure that we're continuing our evaluation of getting to that annual cadence, because that annual cadence gets us to our goals quicker before we can move on to Mars. And we need to align our programs and our performance to get there. So let me turn it back over to Spuds to define the way ahead.
Okay, thanks, Jim. So to finish up, we'll talk about the way ahead here. I mentioned earlier that there's that gap analysis, that bridging analysis that we want to do between the objectives, the 50 objectives that you're going to help us wash, and the current efforts that we have going on. We've already sort of done the internal wash of the objectives, at least at the federated board level. It's all building up towards a second iteration later in the fall. But we're really going to do the remainder of this washing in 4 different ways. 2 are internal. One, internal at NASA, is to solicit inputs from the broader NASA workforce. The other internal process we're going to use is to do that gap analysis I mentioned before at the federated board, where we're looking through the lens of those objectives at our current efforts and look for the potential disconnects there. That's all stuff that Jim Free and his team would be doing if the federated board doesn't exist. But since we do have that leadership there across the mission directorates who can help reach consensus on things such as this, we're doing it to help Jim get a head start as he does the refinement process this summer. But the other 2 sources of washing of those objectives comes in the form of our partnerships, the rest of you, the international partners and the industry partners. For those that were at the Space Symposium, you know that our intent was to host an international workshop later this summer, and then also to engage with industry. The way we're going to do that is through a web-based approach to harvest your inputs, and then hopefully find ways from there how to engage with you further. And all of those are going to go into what I call a cauldron of inputs for these objectives. So we get your inputs, we make a final iteration on those objectives, and then those become an input for another gap analysis that we'll do in the fall after Jim has had a chance to refine the architecture that we have now. And so there you have our methodology that we want to follow in a team fashion with you all to follow those 3 principles of architecting from the right, sticking with the plan, and improving our communication and engagement. We feel that if we do that, we will not only achieve our goal that we were charged with achieving, but we'll also accomplish all of those motivations that our citizens and the folks in our organizations had from when we started. And with that, I'll hand it back to Pam. Thanks for listening.
Thank you, Spuds. Thank you, Jim. That was wonderful. And thank you to everyone who joined us again for your interest. This is an incredibly exciting time at NASA as we prepare to test and validate the foundational capabilities that we've developed with the SLS rocket and the Orion spacecraft, and as we develop a human lander system and the gateway in orbit around the moon. You know, we have a really solid plan for our first test missions, but this is actually a perfect time for us to ensure that we're methodically ticking off the objectives we need to demonstrate our goal of a blueprint for sustained human presence and exploration throughout the solar system, and that we have our eyes on that demonstration on Mars. We at NASA are proud to be America's space agency. We truly want to hear from our workforce, our partners, and our stakeholders what you think about our objectives, particularly if we're missing something. So this video is provided for context. The full list of 50 objectives, as well as a companion glossary, will be available for comments. By the way, if we find your feedback particularly interesting, we may invite you to join us for a workshop to discuss. If you're interested in that, you may voluntarily disclose your contact information along with your comments. Thank you again for your interest in our Moon to Mars objectives.